First off, I just want you guys to introduce yourselves, what your socials are, and then we'll go into opening statements.
Go ahead, AJ.
Yeah, my name is AJ. I'm going to be arguing for the intelligence G factor, mainly the 𝘱𝗲𝗯𝘀𝗃 model of intelligence, 3 stratums. And I'm also going to be arguing for the fact that I believe that G is heritable. I think IQ is heritable.
Okay, so my name is Indian Panini. That is one of my, my nickname on Discord and on TikTok. However, my socials are primarily at Progressive Powerhouse. We have socials on TikTok, YouTube, Twitter, Instagram, etc. These are all, different socials that I have, and that's essentially what I do. Today, I will be arguing two basic things. Number one, I don't believe IQ is a real measurement of intelligence. And number two, I do not believe that IQ is in any way, shape, or form heritable, genetic, or hereditarian. That is what I'll be arguing today.
Sweet.
Great. Okay.
All right, give me a second. I just need to double check if the stream is on because I think there was a. Okay, we're good. Yeah, my internet's gonna crap itself, but it's all right. So if I don't moderate, so you guys can go back and forth. Don't kill each other. No name calling.
Okay, sure.
Yeah.
Yeah, okay, so I want to start out by kind of defining exactly what we want. So, AJ, I assume you believe that IQ is a real measurement of intelligence, correct?
Yes.
Okay, so I assume you know what construct validity is, correct?
Sure, yeah.
Okay, so what I would want you to demonstrate in this first part of this discussion is number one, how IQ is in any way construct valid. And just to explain this to the audience a bit, I want to make sure that I understand like what construct validity is. So construct validity is essentially the way in which we determine whether a psychological test actually measures what it's supposed to. So if we design a test for, say, emotional vulnerability, if that test is construct valid, that means the test actually measures emotional vulnerability. So if IQ is construct valid, it would have to essentially measure intelligence. Now, I heard you say something about supporting the 𝘱𝗲𝗯𝘀𝗃 theory, correct?
Yes.
Intelligence. I believe that the 𝘱𝗲𝗯𝘀𝗃 theory, through my research, this is not so much a theory of intelligence as it is a theory of IQ, correct? Because what it's essentially trying to say is that the correlated subtests in an IQ test lead to some kind of latent factor, which is G, which leads to substratum. You got G, and then the various you got the stratum 2, the broad factors, and then obviously you have the narrow factors there. But I'm more so looking with intelligence, a theory of like what traits are we actually looking for? Like, what determines intelligence? What is intelligence? Is intelligence how fast you're able to respond to questions? Is intelligence how good of grades you get on tests? Is intelligence how fast your memory is? Like, what exactly are we talking about when we mean intelligence here?
Okay, so I think there are 3 questions in there, if I remember correctly. I'll try to go down my list by list. But I do want to make a brief opening statement.
Go ahead.
I am arguing for the 𝘱𝗲𝗯𝘀𝗃 theory of intelligence. And the reason why I am, one of the reasons is not just the empirical consensus, is the psychological consensus as well. The theory, the majority of psychologists accept this theory because of the all the models, confirmatory factor analyses, whatever construct validity, whatever you want to check it. The 𝘱𝗲𝗯𝘀𝗃 model is the most frequently used for clinical practice, for psychological research. This is not just mainstream, this is nearly consensus. As well as the heritability of intelligence. Every survey of intelligence researchers and every survey of psychologists show that the vast majority, over 70, usually 80% of them, agree that IQ is heritable. And if we're just saying just partially heritable at all, it's virtually all of them. And so, for example, Panini asked me ways we can tell that if general intelligence, if G is a valid construct, right? So one thing I will say is, as we've observed G, and for those who don't know in the audience, G, and I think Panini will agree with just how I'm describing it, cognitive abilities, we found cognitive abilities to correlate with each other. And so with tests and whatever means, we can record a bunch of different answers to intelligence testing, and this is one of the most replicable findings, that these correlated cognitive abilities form a factor or an underlying factor of intelligence called G. And so the question I think Panini's asking is, how do we know if G is valid, like by its construct, right?
Oh, well, in a sense, I'm not asking whether G is construct valid, because G isn't a test. G is just a factor that we derive from the correlations between tests, the correlations between subtests. What I'm specifically asking for is exactly what biological processes, what processes are you defining as intelligence, number one. Number two, how is IQ measuring those intelligence or those processes? And number three, is it a causal relationship? I.e., if I increase my measurement on that test, let's say I have an IQ of 99, every time that I have a higher score on the IQ test, am I more intelligent? Right? That is what you would need in order to prove that a psychological test is construct valid. That is exactly what I'm asking for.
Okay, so there's two different lines of reason, two lines of evidence, and for I do want to say first, before I get into my two lines of evidence, is that when we're searching for an answer for something, whether it's like like the Big Bang, or whether it's like human evolution, climate change, what science or researchers usually do is they find lines of evidence pointing in a certain direction. Obviously, we can't record the Big Bang with our video cameras because we can't, but we can use lines of evidence to show us the Big Bang model, right? Is a valid model.
Okay.
And so, for example, two models we can use for the G factor is, the G factor has been observed to be the most dominant construct associated with batteries of cognitive abilities, as well as the most important with respective to predictive validity. For more information on that, if you check out,
Yeah. Just to interrupt there, I actually do have a study that contradicts that in terms of the predictive validity of G versus non-G factors. If I could refer to a study that was done a while ago, or actually it was done pretty recently. Sorry, what did you say?
Is it by Coyle?
Let me make. Try to figure out. Sorry, I have a pretty giant. Here. There's actually two studies. There's actually two studies right here. This one is.
And you can send
this is the one by Coyle, correct? Yes.
Do you want to send it in the
private chat?
Yeah,
for sure.
Yeah, do you want to send the private chat real fast?
Okay.
This is interesting because Coyle doesn't seem like a researcher you would be citing, but
why?
If I'm not mistaken,
yeah, go ahead.
If I'm not mistaken, this article is not saying that the non-G factors predict. Let me double check. But when it's testing G, if I'm not mistaken, prove me wrong by looking at the article, but it's talking about how non-G factors can predict educational and occupational criteria, but it doesn't do it more than G.
Oh, no, it actually does. So if you look at the title of the study, it says non-G factors predict educational and occupational criteria more than G. If you look at
more than G is the series. So when it says more than G, when it says more than G, this is just talking about non-cognitive factors. So like things that are more than G, like non-G factors. There's a colon in between the two.
Well, yeah, no, I understand that. But when you look at the abstract here, it quite literally says that non-G factors are having higher predictive validity than G. I mean, if you go down to the analysis section of the study, you do see that when you look at the various correlations of predictive validity for non-G and G factors, there is in fact a higher predictive validity for non-G factors when it comes to IQ tests. There's also a second study here. This one is, I believe, a replication of the study, which is also another Coyle study, which I believe directly proves the same hypothesis right here. This one's a 𝘱𝗶 study right here.
𝘱𝗶's just the.
Yeah, of course. No, yeah. So this one directly looks at the non-G residuals of tests, and it finds that when looking at non-G factors relative to G factors, non-G factors actually have higher predictive validity than G factors. To explain that to the audience, one of the big arguments in favor of IQ is that when we look at IQ tests, they tend to correlate well with certain occupational criteria. So for instance, like if you take an IQ test and you get really high score, you tend to do better in your job, you tend to get higher educational output. But The thing that's being disputed here is that essentially the concept of G doesn't seem to correlate with these occupational criteria or educational occupations better than those non-G factors that are supposedly worse than the G factor. And I think this kind of highlights how almost useless the G factor is. If you don't mind, AJ, I'd like to go down the points that you listed there, because you did.
Well, I will say
quite a
in
lot of points.
response to that, yeah. Okay. So Coyle's study on non-G residuals and being useful for predicting educational achievement and stuff like that. I will say, when we're looking at if a hypothesis is correct, can we use intelligence to predict? Can we use intelligence or G, general intelligence, to predict outcomes like, let's say, educational achievement, job performance? The scientific consensus is overwhelmingly yes. I mean, this is a newer study.
Okay. So
This guy, I'm pretty sure the non-G residuals are very spatially loaded, and so even still, like these abstract cognitive spatial intelligence does does predict for educational outcomes.
Yeah.
I would imagine that.
So yeah, that's fine. I mean, if you want to assert that the non-G factors are more like spatial or have to do with more spatial intelligence, that's okay. But the fact remains that like these constructs that aren't non-G are in fact having higher predictability than G factors. But I kind of want to move on to the points that you made, specifically attacking my case. So the first thing you said was that there was great consensus for the 𝘱𝗲𝗀𝗀𝗃 version of intelligence. Not only this, but that there is huge consensus about the heritability of intelligence. The fact is, like, consensus in behavioral genetics and cognitive psychology in general doesn't really matter to me. Yeah, well, they are two different fields, but they both work on this. For instance, psychometrics are going to work on the G factor, and the heritability of intelligence is going to be most likely done in behavioral genetics, right? So both of these studies, I don't really value the consensus. The main reason why, I think we talked about this in our last discussion, but is that
what field would you value a consensus for on these topics?
I generally speaking wouldn't value consensus on most like social sciences. I generally would like to look at the validity of data, even in like a non-soft science field. I don't really give much credence to the scientific consensus because okay. So the main thing here, right, is that when we look at the behavioral genetics consensus, when we look at the psychological consensus, right, these consensuses are not in any way, shape, or form like reliable consensuses. It seems like these consensus is essentially just like trying to get a piece, like they basically come to a conclusion and then they work their evidence around that. I'll give you an example. In behavioral genetics, they've been looking for missing heritability of behavioral disorders and psychological disorders for literally like 30 years now. They still haven't been able to find a gene. They haven't been able to find any kind of actual genetic analysis to find like what is causing these.
Well, do you know what missing heritability specifically refers to?
Yeah. So essentially what happened was they have all these twin studies that find these amazingly high heritability numbers for certain psychological disorders, and then you have like the actual polygenic scores and the actual like genetic-wide analysis. These things only find like tiny percentages of genes that like actually do anything, and you have this giant gap, right? And even those genes that do those things are only minorly affected because the proteins that are created by those genes are only like applicable in enzyme level processes in the brain. They're not like actually creating the intelligence, right?
Yeah.
So the fact remains that like these consensuses in behavioral genetics and cognitive psychology, these aren't reliable consensuses. They haven't produced effective results. It seems like they're just trying to reach conclusions because they don't really want to accept the true results of their studies.
I don't know why you mentioned like the behavioral geneticists have been working on the case for missing heritability for a large amount of time when 𝘂 analyses have only been around for a decade or more. So for example, with missing heritability, one thing to, it's like a chicken or the egg, because for example, 𝘂 analyses, they're correlational, right? You would agree to that, right?
They're correlational. I would say that, yeah, of course they're correlational
Right. So for example, it's not all 𝘂 is used to show is like likely genes that are involved in certain phenotypic variations, right? So when we're talking about 𝘂 analyses, trying to say that the missing heritability is proof that the behavioral geneticists are not doing their job is incorrect. Because, like, for example, like, would you say height is heritable?
This thing with the GWAS analysis said like it was like very lowly heritable.
But, like, would you believe height is heritable in general?
Uh, Here's the thing. I base my opinions off of the data, off of the evidence. If you wanted to say like there was an anecdotal consensus of like people who are taller tend to be taller, people who are shorter tend to be shorter.
Like,
I don't know if it's heritable. I don't know if it's like.
All right.
I,
Chill. Chill out. All right, go ahead, AJ.
I do want to say, like, specifically, the scientific consensus. I'm only bringing this up to show, like, the idea is mainstream psychological consensus, right? Like, the ideas are mainstream. We should obviously not say that's like gospel, right? Scientific consensus. I don't want people to think that just because it's consensus, scientific consensus. It's like, yeah, you can throw it away if there's empirical justification against that, right? I've been very critical to academia. But for example, if we're talking about like, so you would say you're not sure if height is heritable.
I don't know. I don't have evidence. If you provided me evidence to say that height was heritable, I would agree. If you provided me evidence to say that it wasn't, I would agree. I like.
Why do you? Well, question. Why do you think the majority of researchers in any field that measures height, or any field that measures genes, or any field that measures anthropometry, or whatever the word is, believes that height is heritable? Like, why do you think?
Well, yeah. Okay. So AJ, like we have to understand. Number one, right? The methods by which we determine heritability. We don't even need to get into that right now. But the methods by which we determine heritability, in my opinion, are pretty shaky methods. But even if I were to grant that is true, number two, I haven't seen evidence on it. If you were to provide me a study that literally said that height was heritable, if you were to provide me like an analysis that I agreed with that had like a model that wasn't controversial, that said that height was heritable to a reasonable degree, I would say, okay, I can agree with you that height is heritable, right? However, I don't have that evidence in front of me right now, so I can't like come to a conclusion.
So it could be equally possible. Like, this sort of fence sitting on, well, I'm agnostic on whether the Big Bang is real, or I'm agnostic on human evolution. Like, in
What?
terms of even something
That's
as
completely
simple.
different, AJ.
I know, I'm using it as an analogy. But for example, if we're talking about something like not disputed, like the fact that your parents can give you genes for height and then like you express them, like, I didn't really like, this should not be controversial. This should not
Well,
be disputed.
yeah.
Um,
Okay, so here's the thing, AJ, right? Like if you were to provide me like 5 or 6 genes, like a polygenic spread of like different genes that cause height, or if you were to provide me like an actual study that said, okay, this is a measurement of height, this is the study that proves that it's heritable, this is why it is heritable. If you were to provide me those analyses and they weren't controversial analyses, these were like consensus analyses, I would agree with you because I only go with the data. I follow the data. I follow the evidence. This is why I'm not agnostic on things like evolution. I'm not agnostic on things like the Big Bang. It's clear that the evidence points to the fact that these theories are correct. But if your theory that height is heritable is backed up by the evidence and is not controversial, I will follow your evidence. I will follow your theory. So if you were to provide me that evidence, I would agree with you. But continuing to say that I'm like disagreeing with like an uncontroversial take is like it's kind of preaching to the choir, like.
I will say, like, if I was looking at psychology, right, and I was saying abusing your kids is bad for them, right? And someone goes, well, I would agree with this, but you'd have to tell me the specific neurons in your brain in order to say that child abuse is actually bad. But it's like,
Wait, AJ, are you making, okay, first of all, that was kind of disanalogous. AJ, in that case, are you making a moral claim or are you making like a scientific claim that like this psychologically harms a child to
this
hit them?
psychologically harms your child, right? Yeah.
Wait, so AJ, you believe in following the evidence, correct?
Right.
Okay, so that
However,
claim is a verifiable claim, right? So like, why wouldn't you believe the evidence?
Specifically, what I'm trying to point out is that if we're looking at things parsimoniously, right? So if we're looking at like if a phenotype correlates with monozygotic twins to a certain degree and to dizygotic twins to a certain degree, right? And there's after environments are equalized, after everything else is equalized, then the variation between the trait is parsimoniously attributed to genetics. Trying to like provide an unreasonable amount, like, like I know some people, and I'm not calling you an evolution denier, for example, but like when I talk to some fundamentalist people who go, well, I would believe human evolution, but you know, what about like they do these what abouts or these philosophical who knows or sort of fence sitting. It's like, yes, parsimoniously, twin studies show heritability estimates. This isn't really this is
AJ, okay, so I understand your point. I understand like what you're trying to say. I think this is a bit of a straw man though. So I follow the evidence. I made this clear. If I
I do
don't
too.
have evidence for a conclusion, either way, I'm not going to say I have a conclusion. I'm going to say I don't know because I'm honest enough to say I don't know, right? When it comes to twin studies, I have an opinion towards those, right? I have an opinion because I believe that twin studies methodology is inherently flawed. And we can talk about that if you want. We can move on to that topic and we can have that discussion, right? But I don't want it to seem like I'm not accepting the evidence. Because what I'm doing is I'm making sure the evidence is correct and that the evidence is pointing towards a desired conclusion. If I can't find good evidence, and if the evidence isn't pointing to a certain conclusion, I'm going to say I don't know. So let's take the example of evolution. Currently, it is literally clear cut that biology has proven evolution. Because that is true, I go with the biological consensus that
Right, we
evolution
haven't found the
exists.
genes. I will say we haven't found the genes that have changed specifically for evolution. But you know,
Wait, but we have but we have found genetic markers that have been passed down through matrilineal DNAs because mitochondrial DNA can be traced back to certain pieces. So we have found those mutations, and because logically we can deduce after mutations, and with environments we can induce certain things about how evolution would work, and because we actually have observed certain species mutating from one species to another species, that is fine, right?
right.
But right, because of that evidence, I support evolution. If
Sure.
we were to
Do you want me
say
to
that
do
there
like
was,
a intelligence gene or something?
do I need an intelligence gene?
Sure.
Um, I mean, I don't think there's an intelligence gene out there that we've found
I
yet.
know, well, genes just generally. I mean, like, I will say this is not a like a argument most people bring up, but like, for example, if people and I honestly, this is what I actually like. If people are like stubborn, sorry to use that word, but stubborn enough to not accept like data from twins or data from GWAS or data from other types of genome-wide analyses that aren't just GWAS for showing that there's a genetic
Hmm.
there's empirically genetic factors at play, then
Yeah.
sure, I'll bring up this. Like I'll put in the chat. Like for example, we did GWAS analyses. This is
Wait.
right?
Yeah. Okay. So sure.
Like we did GWAS analysis. I think it was a Canada gene study actually, and we found like an intelligence gene, and we like put it in a monkey, in a couple monkeys, compared it to other monkeys, and this monkey was like better at intelligence tests. So like, would you
Okay,
accept
yeah.
that?
So first of all, there's a couple of assumptions being made there, right? And this goes back to my first point, which was about the construct validity of IQ. So, number one, right, we have to keep in mind, even GWAS analyses, I'm critical of these, right?
Yeah, me
Now,
too.
they're better than twin studies. I'll give it that. I
They're
think they're
not.
way better than twins.
They're
I do think that they're way better than twin studies because they don't have any inherent methodological flaws. But when we talk about GWAS analyses, I could go on about how like I don't necessarily believe in GWAS analyses, but even this particular like we have one gene that we find that like people who have this
I'm
gene
just
tend to
giving
do
you an
better on it.
example.
Wait. Okay, so this
And we
gene
did
like
experimentally,
wait,
so we
wait,
put it in monkeys.
wait,
All right.
okay, let me finish the statement. So if we have like a gene that we found, right? I believe this one is 𝗱𝗶𝘀𝗰𝗋. So basically, what this is doing is, I believe it's looking at. So it says the brain image and tissue section analyses indicated an altered pattern of neural cell differentiation, resulting in delayed neuronal maturation and neural fiber myelination of the transgenic monkeys. So essentially, it's saying that this gene is what is like it's like significant because humans have this gene. Humans like their brains kind of work this way. But it's also saying that they do better on intelligence tests, right? And this goes back to my first point, which is about the construct validity of IQ. What are we assuming there? Well, we're assuming that these intelligence tests measure intelligence. What is intelligence? how do they measure intelligence? How have we even proven that these things measure intelligence? So I'd like to circle back to the beginning, right? Which is, number one, what model of intelligence are you using besides G, not G, because that's the model of IQ, right? Because that's basically taking the correlated subtest factors and trying to figure out what the latent factor there is that's causing this IQ score, right? But what is your model of intelligence that maybe takes into account things like memory, takes into account things like myelinated pathways, how fast your neurons fire, like these things. Like, if we get a higher score on the IQ test, are these things happening? Do we have a model of intelligence that we can even map this on? And even then,
Sure.
how do we
yeah.
even
So
know that IQ has a causal relationship with this? This is, I'll give you the floor here.
So, for example, the reason, okay, I'll tell people why I subscribe to the 𝘄𝗲𝗯𝘀𝗃 model, right? So there's two different lines of evidence, and I will say we should probably stick on one topic and go through it rather than jump. That's probably my fault.
That's my fault. My computer's crapping itself right now. So I'm trying to,
That's okay.
control it. Yeah,
But so, for example, two lines of evidence. One is validity, so predictive validity. You're combating it with the coil studies. I don't think those are really good. I don't really think those are good. That's a good
Can I
point
ask why?
considering. Sure, like so for example.
yeah, but I want AJ to be able to speak. Give him the floor.
Okay,
No,
sure.
that's fine. Like that's a valid question. So for example, if we check out, like if we look at the large sum of evidence, Strens 2007, which is a popular one if you look it up, or looking at different, virtually all meta-analyses that measure general intelligence, like compared to other IQ, it's like it is the best predictor. So for example, I haven't analyzed too much into like non-G, like residual factors like spatial ability and using that as a predictive thing. It could potentially be a good point. I'll have to look into that. But from what I understand, like one study versus like, most meta-analyses that study IQ and others, I'd have to look into more. But so that's one way prediction, and the other way is, for example, if you do one way to develop models is through factor analysis, right? So for example, if we look at cognitive ability tests, anything that tries to measure different factors, different facets of intelligence, right, we can see what we come up with using model creations that try to measure a latent ability, right? And so, for example, when we've done it with like personality, even though personality just generally correlates with each other, it brings up 5 distinct factors, or depending on how you do it. That's called the Big Five model. But for this psychometric of intelligence, it's not as if the scientific consensus has been going towards a certain direction and going away from a specific direction. And the reason is we've gotten better at psychometrically analyzing how our mind works, how intelligence works, and how cognitive ability works. So specifically, Carroll 1993 does a factor analysis of every single cognitive ability factor analysis at that point in the literature that was reliable, and comes up with the 𝘄𝗲𝗯𝘀𝗃 model, right? Or 𝘄𝗲𝗯𝘀𝗃 model. And that's when I agree. For example, there's meta-analyses using confirmatory factor analysis to analyze if it's a valid theory. And it's not just a valid theory, but it's good enough for clinical usage, right? And so using confirmatory factor analysis, we have like empirical proof that the model of intelligence is the 𝘄𝗲𝗯𝘀𝗃 theory.
Okay, so I've got a lot of stuff to respond to, but I will respond to all of them. So your first point was the meta-analysis of G's predictive validity. Number one, I'm not familiar with this meta-analysis. I would love to see the meta-analysis. If you could link that meta-analysis in the private chat, that'd be great.
It's on IQ, not G specifically, but yeah.
I thought it was about like the predictive validity of G, how that's bigger than the non-G factors, because that's what you were combating, right?
Yeah, so specifically, like I haven't looked into the non-G like residual factors, but so yeah, I'll have to look into that.
Okay, so okay,
if IQ is not like a valid thing, right? Like for example, then it wouldn't really be better than other like things that would predict success in general. So that's why I'm using it.
Okay, so yeah, so that's another point, anyways. But yeah, so when we talk about like like non-G factors versus G factors, I think it's pretty clear that like according to the available literature that I have and that you have, non-G factors do in fact have higher predictive validity than G factors. But that's besides the point. The next
Well,
thing
where in
is
the study
that
does it say? I need a sorry, like I just want to double check that study. Like, where in the study does it say that? I don't disagree with you. I just
yeah,
want
this is this is coil I believe 14. Um, Yep. This is basically it identifies the constructs with validity beyond G, and then it finds that non-G factors or non-G residuals of tests actually have higher predictive validity than G factors of tests, right? So the other point is that
wait, no. On this, it says that the
this
it
is
says
not the,
in general math residual. You're talking about non-G factors predict educational occupational criteria
I
more
just
than G.
I
Talking about
understand.
soil.
I understand we're talking. If you guys want me to share anything on the screen, let me know.
Oh no! I'm talking about the other one. This one is predictive validity of non-G residuals of tests. This is the one on Sci-Hub.
Okay, but the first study you sent, it specifically says in general, math residuals and tilt positively predict STEM criteria and negatively predict humanities, whereas verbal residuals tilt show the opposite pattern. So yeah, no, I 100% agree that if you have a non-G residual that specifically is in spatial and you get it predicts good spatial jobs, like yeah, I didn't, I thought you just meant like educational.
Well, no.
General.
Well, no. Okay, so AJ, so the first study is about like analyzing or like picking out the non-G residual factors. The second study is actually like a follow-up study, which is the one on Sci-Hub, which is predictive validity of non-G residuals of tests, which actually goes over the predictive validity.
No, the first one's also a predictive one. If you read the abstract.
Yeah, but this one is mainly picking out like exactly what like factor analyses are. Sorry, what predictive validity like is for these things, and then the second study is a more in-depth look on the predictive validity of non-G factors and actually finds that there is a higher. If I could like read quote quote, the predictability of tests has been attributed to not much more than G. Contrary to this claim, the non-G residuals of the SAT and ACT predict college GPA almost as well as G. In addition, the non-G residuals of both tests predict verbal and math abilities better than G theories and consistent with investment theories. This pattern suggests that the residuals of the SAT and ACT are in fact better than the G factor residuals. Future research should examine whether the effects of the residuals generalize to tests other than the SAT and ACT, and whether the effects increase over time with differential investment in specific abilities. But let me move on to my other points because
Wait, really fast. How could the Sci-Hub article be a follow-up study when it was made 4 years prior to the other study?
Or am I? Oh, I must have been sorry. The first one, the one on Sci-Hub was the previous study. I'm sorry about that.
Okay, and
I
then
must
the
have
first,
misspoken.
right, and then the follow-up study that was the actual follow-up study does conclude from the same author that the specific non-G residuals like spatial intelligence predict spatial jobs. And even in the first study, in the Sci-Hub study, it's saying that it's certain factors are almost as good as G. But if we break it down
No,
to subsets like verbal, it's better at humanities, which makes sense. We're saying
wait, AJ. So the SAT and ACT non-residual factors predict almost as well as G. However, the non-residual G factors for verbal and math abilities, right? These predict better than the G factors, right? This isn't spatial, right? This is so it breaks down the SAT and the ACT. Those factors predict almost as well, but the verbal and the math abilities they predict better on the non-G residuals.
Well, if this couldn't replicate in his second study, then I don't know what to think of it.
Well, I mean, it finds it in the first study. The second study is about the spatial things. So like AJ, like these are separate things. I mean, if you have counterfactual evidence against these studies, like if you have like a replication of the study from another author that say finds a different like output,
No,
if you
dude.
have like a meta-analysis that finds different results, like stuff like
Is
that,
it- The direct well, I will say the titles of the two are literally the same except the year. This is if I'm not mistaken,
They're
a
not
direct.
they're not the same. No, they're not a direct replication.
Oh, non-G factors predict educational occupation more than G. Predictability non-G. Okay.
Yeah,
Um,
they're different.
but even if we are talking about this, both of them are trying to predict educational and occupational uh, uh, outcomes. If he couldn't replicate his findings in the second study, then
Well, again, the second study is about the spatial the spatial criteria. The first study is
Well,
about looking at
no, these are
SAT, mapping the non-G. Yes, the second study does use SAT and ACT because those are both non-G residuals. The problem is that the first study looks at specifically whether that maps on better than G for certain criteria.
sorry.
It
What
finds
does
that
it mean
verbal
by
and math
SAT?
is
What does
better.
it mean by SAT? I'm sorry. What does it mean by
So
SAT?
SAT and ACT are non-G residuals of IQ, right? Because they aren't like necessarily G loaded in the same way, but they're tied to IQ because they're supposed to predict intelligence, right? Because those things are non-G residuals, it's looking to see whether those non-G residuals have better predictive validity or worse predictive validity than say an IQ test, right? So that's essentially what it's looking at, right?
Wait a second. Reading the Sci-Hub study, it specifically says after using like a explored structural equation modeling, which is a type of factor analysis, literally from the SAT and the ACT test, it can better it better predicts testing. So yes, any model of intelligence coming straight from tests, I assume will predict.
Wait, AJ. Every model of
No, from
intelligence is coming
education,
from tests.
educational tests. So for
Yeah.
IQ tests are going to be different than like the SAT or the ACT,
Well,
right?
those are non-G. Wait, AJ. Those are non-G residuals of the IQ test, right? So every single IQ test, every single intelligence test in the world is going to predict in some capacity the educational occupational criteria,
Right.
right?
However,
Right?
if we're
But the SAT and ACT are supposed to be extremely like correlated with IQ to the point where you can consider it a non-G residual, right?
Well,
So
no,
even if it predicts these things better, all that says, right, is that the G factor itself, whatever this G factor is not in fact the thing that is causing this predictive validity. It is something inherent to the test or something as a product of test construction, right? This is what it's saying. This is literally nothing to do with like whether or not SAT is predicting educational criteria better. This is what?
well, this is an ad hoc model. Like for example, okay, so I do
AJ,
want to break
IQ's
this.
ad hoc.
I do want to break this down. Break this down, like just so it's easier to understand. If you're making a model of intelligence, or just a model trying to find a latent variable, like in making it specifically more complex by adding more covariances or paths, and then approximate it to something very similar to that, right? Like yes, SAT behavior predicts SAT scores. Like if that's how the model is being derived
No,
from,
it's
like
not.
that. Well, yes. So for example, if you specifically
What?
read in the
No,
Sci-Hub
I've
article,
yeah, AJ. So I've read the study.
can I?
The problem with well, you just made a claim, right? Can I respond to
Yeah,
that?
I was going to quote it in the
I mean, you
study.
can quote it if you want. I mean, I've read the study.
Okay, so on page 22, it's talking about the non-G factor can be inferred from the correlation of the non-G residuals by removing the G from the test, right? So for example, if to make a structural equation model, if we're making the model specifically from like data, if we're because it's an exploratory factor analysis, but you're not doing it on anything objective. You're doing it on something like culturally loaded like the SAT,
No, I
right? The
understand.
SAT only correlates with IQ with like a 0.7 but correlation coefficient.
Sure.
So if we're trying to ad hoc a model of intelligence from SAT to produce educational
Wait.
like that,
Okay,
like
so
that,
yeah, AJ. So they're not exactly creating a model of intelligence. See, if you look at the actual table 2, what they're doing
what do
right
you think
here.
structural equation modeling is?
No. I understand that this is they're doing a factor analysis. What they're doing is they're extracting the non-G residual of SAT and ACT because
How
these
can
things.
they do that without doing a structural equation model?
No. They are doing a structural equation model.
That's a
However,
model.
no. How AJ, you need to understand this, right? The thing that they're doing is they're taking the non-G factors that are inherent to the SAT and ACT, and they're saying whether those, whether the test. Wait. Just let me finish. Okay, so the SAT and the ACT, right? They're looking and see if those factors have better predictive validity than the G factors, right? So they're looking at those factors and the G factors and the non-G factors, and they're trying to figure out which has better predictive validity, right? They're not creating a new model of intelligence based off of SAT or ACT. They're just adding on to the G factor model with the non-G residual and then trying to figure out which solves the thing better, right? Which has better predictive validity. This is not in any way, shape, or form like inferring some latent variable through confirmatory factor
What do you think
analysis.
exploratory factor analysis does?
Exploratory factor analysis is basically a statistical tool used to find, like, imagined, like, variables that are supposed to correlate with things. This is different, of course, from confirmatory.
Whoa. That's by definition a latent variable, right?
No, it isn't, because latent variables are
What?
supposed to exist, right? If it exists, that means it's inherent to the model, not like something that's created out of thin air. Exploratory factor analysis are things that basically go into the statistical model. They find variables that are supposed to correlate with subtests, right? But it's not supposed to be a way in which we figure out what. Sorry.
What's going on with the mic? It was screaming.
My bad. My mic dropped from my stand. I'm sorry.
Oh, all right. I thought you were going up to screaming it, but all right.
Oh, no. I'm super sorry about that. No. The basic thing is that, like, confirmatory factor analysis is what you would do if you were trying to find a latent variable, right? But exploratory factor analysis, absolutely. This is wait, AJ, of course.
Anyone in the audience, look this up right now. Exploratory factor analysis is designed to create a model to find a latent variable. What confirmatory factor analysis does is uses that model and sees if the correlations are statistically significant.
No. Okay, so you just AJ, this is AJ, this is actually kind of bad faith, because you just lied. I just Googled exploratory factor analysis definition. Exploratory factor analysis is a statistical technique that is used to reduce data to a smaller set of summary variables, right? And then it literally says here, you use a confirmatory factor analysis to explore the underlying theoretical structure of the phenomena. Let's say I look up confirmatory factor analysis. I look this up. What is the definition here? This is how you find whether measures or a construct are consistent with a researcher's understanding of the nature of that construct, or whether there is a latent variable inherent to the model. So AJ,
Wait a second. How do we know if there's a latent variable inherent to the model if our model doesn't have a latent variable to test, right? So we don't know if there's a latent variable.
Yes.
The model that's created by the exploratory factor. So this is like, you can read any basic. There's a good primer on exploratory factor analysis I had to read. Like, this is something I've been talking. Like, this should be really easy for someone to understand if apparently you have researched this. Yes, exploratory factor analysis creates the model. It designs a model. It tries to find some latent variables, summarize variables. I say the word latent because it by definition is something we're trying to measure, right? Like, that is supposedly exists, right? The only reason why confirmatory factor analysis was created, which was actually created fairly recently, is to see if these relations are statistically significant. And by that point, we could say, okay, yeah, it is. Yeah. You're right. It is a latent variable.
Yeah. Okay. So AJ, you need to understand, right? There's you do understand the difference between, like, a summary variable and a latent variable, right?
For us to call it a latent variable, right?
Wait, AJ, I want you to answer the question. Do you understand the difference between a summary and a latent variable, right?
Yeah. So okay. So for example, I will say because there's some stuff in the middle of this Venn diagram, right? For us to call it a latent variable just scientifically, we would have to have okay. There's two ways of looking at this mathematically and from a scientific perspective, right? So for example, the exploratory factor analyses or principal component analyses, whatever you want to use to try to comb through the data, try to find these relationships, try to find the underlying variables. Yes, that's what EFA does. Why do you think we found G before confirmatory factor analysis?
Wait. Yeah. The reason we found G before confirmatory factor analysis is because exploratory factor analysis inferred that there was some factor. You understand, AJ? Let me. You answered. Sorry. Go ahead. You're the mod.
Go ahead and answer the question, and then let AJ go, and then you can and then go ahead.
Okay, he asked me the question, but I was just answering. Okay, go ahead.
You can answer the question. Go ahead.
Okay, so yeah, the basics here, right, is that in any test, if you have certain variables that are correlated, you are going to find a common factor. That is literally inherent to the idea of certain things correlating. This is like the positive manifold, right? The problem, right, the problem with this is that factor does not infer a latent variable, because latent means that there is actually something that exists. That means that there is some construct that exists either in, whether you're a materialist or whatever, in the brain, right? Let's assume that we're both materialists. We believe that the brain equals the mind, right? If you have, for instance, a latent variable for IQ that's G, that means it exists. That means it's inside my head, okay? Now, that is not going to be told to us by exploratory factor analysis. What is that? Being inside my brain is going to be confirmatory factor analysis, right? So you understand that, right?
So I feel like you contradicted yourself here. I mean, like,
How?
if we're using exploratory factor, so for example, I'll give you an example, right? With the Big Five model, I assume you know what that is.
Yeah, with personality, you just, yeah, sure.
Right. So for example, we used exploratory factor analysis to create that model. Even though some of the personality general factors correlate with each other, right? These personality variables can still correlate with each other, and we can still find the five different factors, underlying factors for personality, right? Depending on how you research it, right? They still
Yeah.
correlate, but so for example, like, this doesn't negate what I'm trying to say. It's like the point of exploratory factor analyses is try to find a latent variable. What I was saying specifically to, the COIA is whether it actually does find a latent variable. Now that's up for debate. That's what CFA is for, right?
Okay.
So
So,
the whole point of me trying to explain why the SAT thing is a weird comparison is because if we're trying to find a latent variable with SAT, right? If we're trying to not a latent variable, if we're trying to find a model from the SAT or ACT and using that model to getting rid of the G and then using it to predict educational outcomes, now you have this absurdly complex model that, of course, right? So if you're making the model more complex by adding more covariances or paths, of course it's going to predict what you want it to predict.
wait, AJ. Okay, so first of all, exploratory factor analysis, as I already listed multiple times, this is supposed to, as I said multiple times, and this is inherent to the definition that I literally did what you asked. I looked it up on Google. It does
Right.
not find. Wait, AJ. Let me finish because I let you speak. So, exploratory factor analysis is supposed to figure out summary variables. Summary variables, right, are supposed common factors. I agree with this. The problem is that it's not a latent factor, right? What a latent
It's not.
factor, as you
Right,
as
right, right,
you and I should
right.
agree that confirmatory factor analysis finds latent factors, right?
Prove the supposed latent factor is indeed a
Or
latent.
finds that there could be a latent factor. That's pretty much what it finds. That there could be a latent factor, or that there's a probability of a latent factor, right? So,
Right. Well,
right, with you saying that they're adding a latent variable to this with the exploratory factor
No, I'm
analysis
not.
in
No,
in
don't start me. Don't start me.
I thought you said that they were creating a new model of intelligence, which
Right. That doesn't mean they're making a latent variable. That's impossible, right?
no. Well, you know what I mean, putting a latent variable or positing a latent variable being there,
Yeah, sure. They're positing a model of intelligence with an underlying factor, right? So right. So it posits it. I'm not saying it's actually there. I'm not saying it's real. I'm just saying the model, because you make your model, you do a EFA on this data. Of course, it's going to make a model based on that data, the SAT underlying factor,
well,
whatever.
no, okay. This is kind of a straw man. So the first thing is when we talk about is this creating a factor? Obviously, it's creating a factor, but the problem is just because it's creating a factor doesn't mean the model is automatically going to always do what the model wants it to, right? Because
Sure, I agree.
the model is being designed in a way to compare whether non-G residual factors work or whether G residuals actually correlate with that, right? Or have higher predictive validity. Sorry, my brain just farted. But yeah, so this is what it's trying to compare the predictive validity of both of these residuals, right? The reason that it's setting up. Why would they do that? Because it's a hot topic.
No, I don't know why they get it from the SAT to promote.
Well, because
stuff
that's
that correlates with the SAT.
Well, that's well, no. Okay, the problem is that if we're it doesn't inherently correlate with the SAT, but when we're talking about yeah, obviously educational outcomes is going to correlate with the SAT, but the problem is people are positing that IQ is this insanely really amazing predictor of intelligence that correlates with all these different outcomes, but the problem is when we look at the non-G residuals that are inherent to intelligence, These non-G residuals don't in any way, shape, or form like have higher predictability than these G factors. So it just seems like
intelligent.
Well, we're talking about IQ, right? I mean,
Right, let's not
like,
call the
like,
SAT intelligent.
here's the thing, AJ. Like, this is a banal point. I'm like, I don't understand. Like, if you have counter evidence to this point, I'd be willing to entertain it. The
You
problem
wouldn't
is,
need counter evidence if the methodology is not fit, right? Like I
well,
don't want.
wait. But AJ, you haven't critiqued the methodology. What you're doing right now.
I just said.
No, AJ, let me finish. What you're doing right now is you're making false statements about the methodology, right? You're saying that the non-residual factors are like, you know, are like inherently going to correlate with these educational outcomes. Okay, so then why are we positing IQ as being a better way to do this? Why are people saying the G factor is predicting intelligence? It is the best measure of intelligence. When these other factors, like the SAT and the ACT, these non-G residuals for IQ, are doing it better, right?
That's
Let me give you.
That's not what anyone's claiming. If you're calling school performance the true test of intelligence, what COIL's doing, then maybe you could posit that. But if you're measuring SAT score to educational outcome, which are two specific parts of what intelligence could predict, then I would see a point. But you can understand why I'm skeptical on if someone makes a model from the SAT and uses it to predict not intelligence, but educational outcome, which is similar to the SAT, then it's like, okay, yes, you made a very complex model for this very specific case, and it works better than the general cognitive ability.
AJ, okay, you have to understand, one of the biggest arguments, you've used this argument before, for IQ, is that you think it correlates with all this different stuff. You think it correlates with educational outcome. You think it correlates immensely with job performance. These are things that you say have predictive validity with IQ. This is why you posit that IQ is a valid way of intelligence, because obviously it's important, because it correlates with all these important factors. So wait, AJ. So if we are positing that IQ is measuring intelligence, right? Because it correlates with all these other factors. It correlates with things like job performance. It correlates with things like educational outcome, right? If it does these things, and we find another way to measure those things better with non-G residuals, why are you positing that IQ is measuring intelligence in a better way than any other test?
Because if you're making a test specifically based on what you want to find, then it's not a very good test.
Yeah, of course, if the model doesn't predict well, it's not a good test.
Well, not just predicts well. Let's say I do the, okay, how about we find, I could supposedly make the new model of intelligence where I write down all the correlations of John, the grilling lizard, right? And then I call that my model of intelligence. And I test it with John. It turns out to be the best predictor ever. The best predictor. You could see why someone could go, whoa, wait, you just ad hoc created a model. And yes, it correlates extremely well. Good job. But you can understand why this is a really poor way to create a model.
AJ, wow. I'm glad this is amazing, because this is exactly the reason why
and I can explain why
IQ is bad. It's an ad hoc visualization of this. Why? Okay, yes, this is exactly why. Okay, so they came up with a version for intelligence, John the Grilling Lizard. We decided to create the John IQ test, right? It correlates amazingly well with John's intelligence. Wow, amazing. In the same way, we take IQ as a score. We say, wait, AJ. So we take IQ as a score. We say, okay, we're gonna measure intelligence with this test, right? People take the score, they get measurements, and that correlates very well with things like educational outcome, job performance, things like that. Like we say, okay, this is a very important test. Now, that is an ad hoc visualization of that test, the same way that everything else is.
By definition.
All right, let AJ go. Thank you.
And the reason why it's not is because it's not generalizable. So if you look at COIL's data, the model he's used is not generalizable to make predictions about any other thing like job performance or reaction times, right? So what's cool about the general factor of intelligence, it is it is generalizable, right? So for example, the reason why I say this is because we didn't get this model from looking at some subset, but using all cognitive ability. So here's one way to look at this, and I think this might be enlightening for other people, right? Because generalizability is a really important thing in psychology, right? So for example, there's a study that replicates it. It's a confirmatory factor analysis that measures general intelligence, and specifically on different oh, okay, there's two lines of evidence here, right? If you look at confirmatory factor analyses that do it on completely different types of tests, the same statistical G is indifferent from each other, right? And I'll send this in the chat right now. So if we look at different types of tests that aren't supposed to find, like, it's so funny because like the makers of some of like these IQ tests are, they really don't want them to correlate to G, right? However, as people do confirmatory factor analysis from the G model towards these intelligences, the G factor that's found from all these different batteries, not just batteries, all these different independent cognitive tests find the same statistical G.
Yeah, okay. So if I could respond to this. So there's a couple of things here. The main thing that I generally like, I don't find that compelling is this idea that like G is this perfect thing. The main model of intelligence that I go with is mutualism. This is the thing that I like to push because mutualism is while not extremely well credited, it's a pretty new model of intelligence, obviously. But in my opinion, it's better than G. I'll drop some sources in the comments here. This one is 𝗲𝗯𝘀𝗋 et al. 17. This one is the new model, which accounts for things like the Jensen effect and all that stuff. And then there's actually some stuff about why it's better than the G factor. If I could cite some of these studies. So this one is Peng et al. 19. It's further evidence for mutualism and against G. This is a meta-analysis. The next one is this study right here, Palmer et al. 20. Right here. This is further evidence for that. And then finally, this is one from McFarland 20. This one is talking about how the differences between mutualism and G create this kind of very interesting relationship. They stress how the validity of the mutual model basically renders the search for a gene or brain area almost useless. To explain to the audience a bit about what mutualism is and why it's a preferable model, essentially, mutualism is essentially a model of intelligence where you have all these different cognitive abilities, like math abilities, verbal abilities, written abilities, etc. And through positive reinforcement, these abilities correlate with one another, right? That's essentially what the mutualism model. So it accounts for the correlations, but it also posits these things as being individual factors latent in the brain. Now, you can go ahead, AJ, if you have some rebuttals to mutualism. Go ahead.
So question, did the models that test G and mutualism, did it specifically test the 𝘄𝗲𝗯𝘀𝗰 model?
I believe that's the major model that's testing, because Spearman's G, as of right now, is like completely outdated and just not used because it's like.
Can you check? Because like there's some mutualism things where I don't think they tested. They either use like a bifactor or just a plain G model, but
Yeah,
I'm
no,
not
no,
sure.
no.
Can you check in the study if they actually use a 𝘄𝗲𝗯𝘀𝗰
Yeah, no,
model?
no. I believe most of, yeah. The first one, the meta-analysis, uses like a lot of different models of G. The second one, that one is, I believe, the cow. Let me check this one.
Or 𝘄𝗲𝗯𝘀𝗰, should I say?
𝘄𝗲𝗯𝘀𝗀. Yeah, the second one is definitely 𝘄𝗲𝗯𝘀𝗀. And then the third one is a book. So yeah, I mean, yeah. But yeah,
Have you read it?
I breezed through it. Yeah. But yeah,
Okay.
that one looks at a bunch of different models, including the 𝘄𝗲. Yeah. So this is actually another one. This is called Stability of Factor Loadings from 𝗷cie𝗶𝘵. This one looks specifically at 𝘄𝗲𝗯𝘀𝗀𝗃. Is this one? Oh, no. This one's the wrong one. Oh, sorry, that I'm wrong. That one looks at bifactor. But yeah, this is just general evidence for mutualism in favor
Well,
of mutualism and against G.
if it's only comparing like, with a bifactor model or a plane
Well,
G,
well, AJ, that was the one that I haven't cited yet. I didn't cite that one yet.
okay. Let me read. You said the second one specifically tests a 𝘄𝗲𝗯𝘀𝗃 model.
I believe so.
The penguin or
Oh,
the
no, this one's different. No, I'm sorry. The first one does. That's the meta-analysis. That one is completely like it goes over a bunch of shit.
the van der Maas one.
The van der Maas one is the setting up the model for mutualism. That one's not rebutting G.
Well, it's set up in 2006. This was a 2017 one.
Well, no, this one is the updated version of the 2006, because the 2006 was the original model, and then this one accounts for like critiques from Gignac and I believe a couple other people, like the Jensen effect and some other things.
So how did they update the model by just like they use the exploratory factor analysis, or did they just manually just make the model fit better?
Well, what they did, right, was so Gignac had responded by saying a couple of things. Number one, he said that there was like he critiqued the Jensen effect and some things like that might have implemented. There's also stuff like obviously the Flynn effect, which needed to be accounted for in the model. So they, of course, incorporated these things into the model by trying to map it better, and then they tested the model again to make sure it was also good and it actually mapped onto the factor analyses better, and it actually did better than the 2006 model. So yeah.
Okay, let me check. I haven't read the study before. The meta-analysis of the relationships with the penguin. View text. There are some things I am curious about. Let's see, how long is this?
I mean, I don't want to get reading studies during the debate. I feel like it's better if we just like kind of
I'm just breezing through it.
Okay, sure. I mean, I would like to move on to some other stuff. If you would want to.
To it. So,
yeah.
I mean, if age is okay, we'll go on to another thing. Just and then come back to. Unless AJ wants to stay on this point, it's up to you.
Yeah. So I do want to make some. I do want to state some questions about 𝘄𝗲𝗯𝘀, the mutualistic model.
Sure.
So, for example, let's say it is the case, right? From what I understand, tell me if I'm getting this wrong. So we believe, if I'm a mutualist, we would believe that there are different cognitive subsets or whatever we want to call it, and the reason why the positive manifold occurs is just environmental stimulus, whatever it may be.
Positive reinforcement, yes.
Positive reinforcement from, I assume the environmental factors, right?
Sure, yes.
So wouldn't we see like the variance of G, like wouldn't we see the proportion of variance in with the general factor of intelligence like to change like from people as they age? So like the positive manifold will increase?
I don't think that's necessarily the case.
Well, how would
I would say that
in the first place?
Okay. So this is a bit of a weird question because you're basically asking like how much of their intelligence is due to the general factor, but it's more
no,
so
just
like
correlations. No, specifically.
Yeah. So what we do actually find is that like older people tend to have like more correlations between the subtests. Like they actually tend, like the subtests correlate higher when they're older, and when you're younger tend to be a little bit more variable. So this is actually accounted for in the van der Maas 17 study, which is actually like one of the huge things that were like supporting mutualism, is the fact that these like things variable. If we're talking about like G loadings on specific tests, right? G loadings on a test are always going to stay static, like the G loading on the Stanford-Binet test or the WPAS test, or say like I don't know, a special IQ test like the bitch IQ test. But the like all these different IQ tests will have different G loadings, and those G loadings are going to stay static. The main thing is whether your IQ score or the subtests on those IQ tests are in fact correlated to a particular degree.
Well, for example, one thing that I was looking at some of the replies van der Maas and Kahn had with like Gignac, for example, but I don't think van der Maas or Kahn could get past the fact that like the variable g stays the same, like just when from when you're 3 to when you're basically 90, like the parts where g correlates with cognitive, the part specifically where the positive manifold is represented. So I'll
I
send that
mean,
in the chat. You probably have this already,
is it
but
𝘂𝗋𝗃?
yeah, you probably have read this already. But
Yeah, this is
how
𝘂𝗂𝗃.
how
Okay.
how would you respond to the fact that like
Yeah.
the variance of G does not seem to go through any positive reinforcement change, like
Okay. Yeah.
from when you're 2 to 90?
Okay. So, were you talking about like the variable g doesn't go through change?
No, the variance. So, for example, if you're looking at G, the proportion of variance in scale scores accounted by the general factor.
Oh, well, okay, so the proportion of the variable factor g is going to stay
We'll make
static.
a hierarchy.
I mean, like that's inherent to the model, right? Because certain IQ tests are going to have certain g loadings because of the way they measure those questions. But when we're talking about, say, like, why does this stay the same? This seems more simple, right? This is one of the biggest things that 𝘂𝗋𝗃 actually appealed to was parsimony, right? But parsimonious explanations for problems aren't necessarily better.
Parsimony?
Like parsimony, like it's simpler.
Parsimony.
Yeah.
Yeah.
Sorry, did I pronounce it? I have accents
You're
sometimes.
fine, you're fine.
Okay, no. It's basically where like having a parsimonious explanation can be great. Like sometimes having a way, like a simpler way to explain things can be really good. The problem is if that simple explanation doesn't explain something as well. This is like the Occam's razor problem, right? If I have explanation A and I have explanation B, and explanation A is simpler than explanation B, and they both measure, like they both have the same level of explanatory ability, I should probably choose explanation A because it's simpler, right? But if explanation B is more complicated, but it explains the phenomena better than explanation A, then we should probably go with explanation B, right?
Okay. Yes, I mean, like for example, if we're saying if it's easier, like I could attribute human life to God, right? Maybe a not omnibenevolent God, but I could attribute all human life to God, and that would be a really, that would be actually a really complex model, but it would explain things a lot better, right? We wouldn't have to like try to find abiogenesis or anything like that if we just attribute it to like a but like for example, the reason I don't find this we could ignore Occam's razor appeal is one, this is not just something you can like breeze over, right? This is because that's how the authors of the study responded. They went, well, this might not the empirical data might this specific empirical data might not match the model we propose, but if we form our model, like it can predict better. And the problem I have with that is the whole entire gist of the mutualistic model is the fact that the positive manifold increases over time through reinforcement, right? If it's not increasing over time, this doesn't show enforcement, and this like there's not actually
Wait,
proof.
but AJ, okay, there's a couple things. So number one, so Occam's razor, again, like the simplicity of an explanation doesn't necessarily mean that
I don't care
explanation
about
is
the
better.
simplicity.
Wait. But AJ, this. Let me finish because I said a couple things there I might disagree with, right? So number one, when we're talking about like whether a model works, we have to look and see like, does this model explain a phenomena better than another model? It seems like if we look at the general data, like psychological analysis, right, the positive manifold, or like how much subtests are going to correlate with one another, does in fact increase as you age. That is true, right? Like Vandermas 06 and 17 both address this phenomena, right? One of the ways that like G factor gets away with this is by saying that like as you grow older, you get smarter, and the G factor encompasses more of your intelligence.
Well, not smarter.
Right? Well, yeah, I mean, like you have more intelligence, right? Because like your brain is growing, and the cognitive processes between like different parts of the brain are growing. Like neurons fire faster, things like that, right? Like this is the G factor would get away with this by saying like G factors increase, but this just seemed like a cope because they were just like ad hoc generalizing it, right? But right, when we actually incorporate this model of mutualism, when we look at these different individual factors, right? Like we have to make we basically make the inference that we basically create this model, and then we look at whether it explains the phenomena of intelligence better, And it does, according to Vandermas 17, according to Vandermas 06, according to Penn 19, according to the other studies that I put there.
17 isn't even that good.
Well, can you explain why, though?
Yeah, because they did the same thing Coyle did, right? They made a model. They literally, the data they had, they made I haven't read all of the mutualistic versus G models, but like a lot of these ones comparing, they literally just make a mutualistic model from the data they have, import a G model from somewhere else, and then test it. And not just test it, but like if you're using an EFA for the data you already have. Okay, actually, I don't want to get into this point yet because I do want to respond to,
Okay.
I do want to talk about the GigNac thing, but okay, like I could understand, like, okay, maybe this is like a small, if there's like a small thing that mutualism can cope from, but by definition, the entire model of intelligence is based on increasing reinforcement, creating the manifold. If that's not there, the model's not correct. Just because it explains something better isn't really a good quote unquote cope, right? And the reason why I say that is because if your model, like if I say God is a really good model for explaining X, Y, and Z, but we'd actually have no empirical evidence to prove it, then that's not really scientific, right? Like if it's unfalsifiable, right? Because if you're making a model just to fit the predictions, but you have empirical evidence against it, then why would you use that model?
Well, okay, so AJ, so first of all, right, the model that was created for mutualism, first of all, any model that we have is going to be like created, and then we take that model that was created, and then we see if that model explains the phenomena, right? So in this case, right, we have the positive manifold, which increases due to age, right? That is an absolute fact, right? That fact, right?
Wait,
because
no, that's what I'm like, because we've noted. So okay. So
you're disputing the fact that like subtest scores correlate more as they increase and as you increase in age.
look at the study I just sent you from GigNag. It literally tests the proportion of variance in scale scores accounted by a general factor from 2 to 90. If you look at figure 2 in it, yeah, look at figure 2. Just open up in Sci-Hub or something. That's illegal though, so don't. But
That's fine.
That's a joke.
I've read the study of GigNag. It does not in any way prove that subtest scores don't correlate more to age. What this is proving, like the two main.
Why does the age graph show that the subtest correlations don't increase with age?
Let me put this inside. Let me put this in Sci-Hub.
By the way, the omega hierarchical is to define it's the proportion of variance in scale scores accounted for by whatever factor you're looking at. In this case, the G factor. Right. This is the big, like, if this were a smaller criticism, I could understand.
Wait, one sec. Where's the age?
Figure 2.
Okay, so these are the correlations.
Here, let me open up in Sci-Hub 2 just so I can see what you're looking at as well.
Oh, yes, I've seen this before. Okay, so this table was like historically disputed by
Historically?
Or sorry, my bad. This was disputed by Vandermas 17 and the various responses. I believe there was a response actually in Vandermas 2016. Let me find this one. It was a response to GigNac. Vandermas and Kahn, yeah, right here. So right here, this is a response, of course. And they actually dispute this graph, right? Because they find that they were basically this graph was looking at the strength of the G score and not necessarily looking at like the actual like subtest correlational scores. This was like there was like a lot of stuff, like some of the statistical stuff went past my head because obviously I'm not a major in statistics. But when we looked, they disputed the graph, they disputed the findings of that particular thing. It's like obviously true that when we're looking at the correlations between certain subtest scores, as you increase age, right, these things are going to increase, right, because intelligence will increase over time. Your intelligence is going to heavily be influenced by your age because as you grow older, your brain develops further, and obviously that is going to occur. Okay, that's.
Okay. Another. Okay, then we can move on to a different topic. I think we've exhausted that.
Okay, sure. So if we can agree that the evidence currently supports the mutualistic theory,
No,
Or we
I
can
don't
agree.
think that.
Well, okay,
I
I don't, I
absolutely.
don't. Well, I don't really understand why, because all your criticisms of the mutualism theory have been kind of answered, or so do you have
Well,
like
just
another
because.
criticism of the mutualist
Well,
theory?
for example, they didn't just respond, but they were saying lex parsimony as the response. I was reading it, and you even responded like because you remembered that. So
Yeah.
so them responding with lex parsimony is a really weak counter. There's
Well,
other and there are other um, critiques to mutualism, right? So, for example, it's like if the positive manifold is something artifactual, more or less, or like an illusion, then why would it have genetic correlate? Why would this positive manifold have uh, uh, genetic correlations, or why would these specific cognitive variables have genetic correlations with each other, right? It
what do you
would
mean
be
by
really
genetic
hard.
correlations?
So here, I'll send you this. Um, Giuliano.
You understand that like gene environment interaction happens. So even if this was the case, like
Okay,
it
but
could
even
increase
still,
over time.
gene environment interaction, like this is, I feel like this is a really poor argument because meta-analyses, and I can send you some as well, that try to that do quantify gene environment gene environment interaction, show nearly statistically insignificant nearly insignificant effects, specifically with complex traits, one of them being intelligence. And so, for
Wait.
example,
Okay. Can I ask you a question though?
and even still, last part, a gene
Okay.
environment
Sure.
correlation in twin studies is measured by environment. So if you really wanted to test it, just look at the environmental variable.
Oh.
But go
Okay.
ahead.
Well. Okay. So, not necessarily true. But okay. So when we're talking about like whether these things have genetic correlations, like even if the positive manifold had genetic correlations, we have to understand that like genetics isn't this like monolith where like if I have a gene, it will do this. It's gonna code like no.
I agree.
Like like genetic expression is a thing. Things will grow over time. Certain proteins will be produced in a more in a more profuse manner due to introns and like in between DNA, like stuff like that. You understand that, right?
Sure.
Yeah, okay. So even if there is a genetic proponent, that doesn't entirely destroy the mutualist theory. In fact, it might even strengthen it. So, like, when we look at this, like, let me actually look at this article because I haven't heard of this before.
Well, I mean, this is a pretty common finding. It's like
Biometric
the
special mention is multivariate tune intelligence code scores.
so if you look at the part where it says quote unquote, you can control F this if you want.
Sure. What does it say?
It says correlations between phenotypic G loadings and genetic G loadings were 0.88 and 0.76, which is pretty dang high. For the two mental
Genetic.
test batteries, specifically, they did the WAIS and some other
Okay, so this says in the paragraph below this one, this was investigated further in a Dutch twin study, which 194 pairs took Raven's progressive matrices at age 16.1 years and the WAS at 17.6 years. So, AJ, I think I've made this clear. Like, I have problems with twin studies. So, like, I mean, I don't know. That would be a whole battle that we'd have to go through. That'd probably take an hour long. On the equal environmental assumption and all that jazz. And even then, you have to overcome the philosophical problem of like, is the mind real? How do we account for consciousness? Things like that, right? Like these are problems that like are inherent to the field of psychology, right? Like things like that. So we have to understand that when it comes to the G factor, when it comes to mutualism, like overwhelmingly, the evidence seems to point to time and time again that mutualism is the better model, especially with a lot of these studies. Sure, before the mutualism model was created, I would agree the G factor model, like in the wait, AJ, before the mutualist model was created, I would agree the G factor model of intelligence was the preferred model. That is true, right?
Well, not just preferred. Not just preferred.
No, I agree. It was the consensus model, but
not just consensus,
right?
empirically proven.
Wait, AJ. I understand that it was quote unquote empirically proven. Again, I would dispute that empirical proof, right? But if we're talking about like right now in the current cognitive psychology, there's still a huge debate going on over whether it's mutualism or the G factor. Like, right? Like,
73% of psychologists prefer a 73% of psychologists prefer a G model. I think like
Yes.
10 prefer a independent like Gardner theory, and then there's like a insignificant amount that promote a mutualist model. And this is
Wait,
from 2020 surveys.
okay, wait, AJ. So right now, like before, that support for the G model was like way higher, right?
No.
But
So for example, if we look at
yes.
test scores from 2013, it was around the same. If we look at survey, I meant to say. So if you look at survey scores from 1987, you do a general mainstream science of intelligence by Gottfriedson in 1999. If you look at the survey from Rinderman et al. In 2013 and the one in 2020, the support for G has remained constant.
Yeah, but again, AJ, right? Like we have to keep in mind that the mutualism model is supported by the evidence I have provided in this debate. If you have no way to counter that evidence, what you are doing is you are saying that you cannot provide an alternative here that is sufficient to overcome my evidence. All you've done, like
I
you just
have.
kind of, what have you provided that has countered my evidence?
Well, for example, if the omega G variable doesn't vary throughout the age, then there's no positive manifold from
Again,
interpersonal correlations. If there's genetic correlations, then it can't just be an artifact from reinforcement from the environment, right? And there's like three or four other things I could say.
Okay, I'll respond to all of those. So first of all, when it comes to the one in the Gignac study, again, I provided the Vandermas and Kahn rebuttal to that, which
That wasn't a good
disputed
rebuttal.
which you said it appealed to parsimony. You didn't challenge the rebuttal to the graph. You said it appealed to parsimony.
Parsimony doesn't even appeal. It doesn't even rebut what Gignac said. Because what the authors said in their response was, even though despite this minor inconvenience, like it doesn't have to be the model that fits most with the empirical data. We just use it because they base their model off of prediction. That's a really flawed way to look at it, because anyone could make a model from whatever they want, and if
Yeah. Well,
right.
I mean, like AJ, they made the model and then they tried to test it to figure out if the model explained the phenomena better, right? And it did, because that is what they found in all of the Vandermas studies and the studies that I provided you. I mean, I could source stump you with the amount of mutualism studies that finds
I know
that
you
like
could.
the phenomena. So like when we're talking about this, if you don't have a rebuttal to the critique of the
Well, if you don't
Vandermas
want
and
to give
Kahn
one,
graph critique, then I'm sorry, you don't have a sufficient counterfactual to prove me wrong.
I feel like I'll say it again if you'd like, but like for example, if you're creating a model from the data you're using to prove you the data you're using, then yes, I cannot empirically prove that model is wrong. I mean, I agree, right? But when we're using when we're making models, we have to, like I said previously, make it generalizable, right? If these models aren't generalizable, then they're not models for intelligence. The G factor has been found not only cross-culturally, but in chimpanzees and dogs and donkeys, right? Like the G factor is a model of intelligence that expands across not just humans. This is a mammalian thing, right?
Yes,
The G
yes,
factor has also been proven through confirmatory factor analysis,
yes,
right? Not just.
and in the
Sorry,
fifth,
the last part.
yeah. Okay, go ahead, go ahead, AJ.
Because let's assume that the mutualism model was correct. We would find that the positive manifold would be different because, different correlations, right? So when people are taking different batteries, I'll send you this, the Johnson study, really fast. There's one here, and there's a replication of it. If we assume that both these Johnson studies of confirmatory factor analyses across different IQ tests were, if we assume the mutualism model to be correct, the G would not be statistically the same as the same G in other tests that are trying to measure different things, right? If there's a G factor, we would expect that the G's are statistically 99 to 100% the same as they see in these test batteries.
Okay,
And
so
these IQ
yeah,
tests at large.
so firstly, back in the 1500s, I'm sure people thought spontaneous generation was the best model. I'm sure it went across
Okay.
all places. The problem is when our evidence updates, when our knowledge updates, we come to new conclusions about the evidence. We decide that there are new models that we can use to explain phenomena. This is how science works. This is how science has always worked. Now, if we're going to talk about, wait, AJ, let me finish. I let you talk, okay? So, if we're going to talk, right, about whether or not the positive manifold is genetic or environmental, again, even if it is genetic, it still does not counter the mutualism theory. Because again, you have things like gene-environment interaction,
I
right?
explained why that's not a really important factor.
But AJ, don't interrupt. AJ, so there have been numerous like studies done on how the gene and the environment are literally inseparable. I can provide you so many different studies on that. And then the third thing is that even if this was entirely genetic, there are still problems with introns, with interactions. There are still problems with epigenetics, with things that exist outside of the Mendelian genetics, where if you have a gene, it automatically goes to a phenotype, right? These are things that are different. These are things that need to be analyzed on an individual scale. So to reductionarily just kind of say, oh, because the G factor or because the positive manifold is genetic, it therefore cannot be true that the mutualism model is valid, is very reductionary. Well, you did say it reduces the probability that it's correct.
This is not what the mutualism model would predict, right?
Well,
the mutualism
would,
empirically, why would okay, I'll respond to some different points. It's like, of course, I don't believe in Mendelian genetics. It's like, this is the fourth law of behavioral genetics, right? The fourth law of behavioral genetics states that no specifically complex trait is done by one gene. I obviously agree, right? This is not disputed. Another thing, epigenetics and gene-environment interaction. One, these are measured in twin studies already. If you look at epigenetics, that's measured under the non-shared environment, right? And we've looked at epigenetic effects with specifically complex traits. And I don't have the study on hand. I should probably have it. I made a TikTok on it a while ago, but there's not any statistical significant effect. Like, these are very like last resort arguments to try and stop like the general empirical consensus. Like, for example, the gene environment interaction thing you're talking about is not supported by any of them, what do
you mean it's not
supported by any quantitative analysis to be statistically significant to any degree?
Okay, so first of all, right, this is just simply not the case, right? Let's talk about firstly this idea that like it's in the non-shared environment. So first of all,
that's how the Falconer formula works.
Well, with twin studies, right? Like obviously, like there's so many problems with twin studies. Like the major problem you're gonna have. Okay, so like this is like the major problem with twin studies is that like you're supposed to like account for consciousness, right? You're supposed to assume that both people's consciousnesses are exactly the same, right? Because if you don't assume that, then you're assuming a level of like philosophical variability, right? So you have to overcome that hurdle and prove that the mind is like a material entity, right? Which maybe you can't even do, right? Because that's like a huge problem with psychology in general. But then secondly, you have the problem with the equal environmental assumption, which you're assuming.
Like a supernatural argument?
I'm making the argument that you cannot prove that the mind is material, right? So, because you cannot prove that the mind is material or that consciousness even exists in a material sense, then you cannot prove that you can account for consciousness in a twin study. And I don't think you can make that argument, right?
Okay.
I mean, sure, I would love to make the argument that we have found no supernatural effects on the mind, right? All human behavior, even Vosh admits this, all human behavior is genes expressing themselves in environments. It's like I'm a determinist. I don't believe in the supernatural. I don't think scientific models should incorporate like, whoa, what if consciousness is some sort of abstract, non-material?
Well, that's a philosophical debate, AJ. So why would you supersede that?
That's a supernatural appeal.
It's not a supernatural appeal, AJ. So here's the thing, right? If we don't know whether the mind is material or immaterial, right? Like, why in the effing world would we just like assume that we could control for it and say that this is like a correct way to do a study?
Why are we thinking our brain is different from any
I don't know whether it is age. This is the same problem that we ran into the first time, right?
No, because like this is not just like, okay, I could at least sympathize with your first argument. I do think this is absurd. Like I could claim, I don't know if my hand has some type of independent consciousness apart from my genes. Who knows? Like, I'll be agnostic. I don't know
That
if
is
my
so
hair has,
different, AJ. This is
right?
such a straw man. AJ,
You
okay.
have no. The burden of proof is on you to explain why your brain is different from any of your organs and has like some sort of abstract,
I'm not
non-material. The
AJ,
burden of
okay.
proof would be on
No,
you.
no, AJ. The thing is, I'm not even making a claim as to whether it is or it isn't. I'm saying we don't know. This is the same thing that we ran into in the beginning, right? You
No,
are
no,
making
no.
the wait, AJ, don't interrupt. You are making the claim, right, in the beginning of this debate, right, that the mind is a material entity that we can measure, that consciousness is a material entity that we can measure, and that intelligence is a material entity that we can measure. And you're saying that it's genetically influenced, right? So number one, you would have, that is your burden of proof. You are making the positive claim there, right? Right?
That there's no supernatural elements in
That the
humans?
mind is material. You would have to prove that.
What's immaterial? The supernatural.
I'm not saying that there's anything immaterial. I'm saying in order for you to prove that the mind is material, you would have to have a burden of proof to prove that.
Yeah. Okay, this is unfalsifiable, which is unscientific. Like, this is literally some sort of pseudoscience, and I'll explain why. This is unbelievably pseudoscientific, right? And the reason is, it's like trying to say, well, some third party effect could be affecting something simply genetic and environmental, right? Because, okay, genes express themselves in environments. Humans are genes expressing themselves in environments. That is literally it. If we're trying to claim that there's something abstract or beyond the genes in the environment, the burden of proof is on someone else, because this is not just the scientific way to reason things is that things are material. Like, there could be God, right? Maybe the burden of proof is someone to disprove God, right? No, that would not make sense in a scientific debate. Maybe the burden of proof is on someone to disprove that aliens are. No, it's like, when we're doing a scientific debate, we are on the justification, we're on the same idea that the things we're studying are materials, are a material.
AJ, can I explain something to you, right? So when I'm saying that we don't have an answer to this question, right? Again, at the beginning of this, wait, AJ, at the beginning of the debate, I said I don't know, right? I'm not making a claim. In this way, I'm not making a claim as whether the mind is material or immaterial. What I'm saying is that we don't know the answer to that question. You are specifically saying that this is an unfalsifiable assertion, therefore it is true, right? This is not an unfalsifiable.
No.
Wait, AJ, can
Newton's
you
flaming laser sword, bro.
AJ, shh.
Newton's flaming laser sword,
AJ, my turn. Okay, so when we're talking about philosophical debates, right? The main way that we normally do philosophical debates is by a process of creating syllogisms, right? Creating arguments, right?
Sure.
If you were to provide me a rational argument for why the mind is a material entity, then maybe we could control it in a scientific study. But if you cannot provide that assertion, if you cannot provide that, that is the brain. That's the brain. That's different. That's totally okay. There's a difference in most philosophical debates between the brain and the mind, right? You understand that, right?
Okay, yes, but we're not talking about abstract philosophical theory. We're talking about empirical. This is a scientific debate.
I understand you think, okay, this is a scientific debate. I understand. The problem is that when we're dealing with things like psychology, when we're dealing with things like comparing two kids' intelligence that happen to be twins, we're assuming that both people's consciousness are the same thing. And in order to do that, we have to, one, prove that the mind is material, prove that consciousness can be the same, and then third, prove that the environments are even the same between the two twins, which is the equal environmental assumption, right? So you've got three things to do here if you want to prove that twin studies are valid. Number one, close the philosophical debate on whether the mind is material.
Okay,
two, figure out whether the consciousness. Okay,
sure.
Go ahead, do that.
Fine.
Do that for me.
Since consciousness and mind, these abstract concepts, are not material or immaterial, even if they are material or immaterial, it doesn't really matter, because if they are material, then they express themselves genetically in an environment. If they're not material, then they don't matter, because this is a scientific discussion.
Well, 1 second, I do have to ask, Panini, is there a way to lower your mic or something?
I don't know how. Maybe I can try. Give me 1 sec.
Okay, if you can't, that's fine. Yeah, I agree.
Is this better?
Because
Is this
he's
better?
screaming and AJ's like whispering, so it's kind of.
Is this better?
Yeah, it's better.
Okay, I lowered the gains on my mic, so that should be better. Okay, so let me address something, AJ. When I say that the mind is non-material, what I mean is that we have to reckon with the idea that, like, our consciousnesses and our minds are not expressing themselves in a material manner, right?
Why?
Can they be measured, right? Like,
No,
this
no,
is
no.
a
Why? Why would
question.
the first point? Why?
Why?
Why would we have
Well,
to reckon
why?
with something unfalsifiable?
Well, because this is a debate that we don't know the answer to. If we don't know the answer to this question, why would we say that, like, we can just
Because if it's a
assume
material,
one way or the other?
because if it's immaterial, then we don't have to measure it because that's not
If
a
it's
scientific thing.
well, okay, so if it's material, we can't measure it. How
No,
is
if
that an
it's
argument as
immaterial,
to whether it's material or immaterial?
if it's immaterial, then we don't have to measure it because this is literally psychometrics, right? If we're measuring things that our brain
Yeah.
produces,
So
right? If it's
yeah.
producing immaterial things, regardless, it doesn't even matter because
So AJ, you're
these
agreeing
things
that.
if these are coming from our genes, right? If we factor for genes and these things are coming genetically and manifesting themselves genetically, we could be supernaturally manifesting what we have genetically. I don't really care. then it's still factored for genes.
No, okay, AJ, you have to
If our
understand.
consciousness is coming through genes,
Okay,
it's
AJ,
factored for genes.
okay. Let's take this one step at a time, okay? So you agree. Let's say that the mind is immaterial. Let's say that the mind exists in some dualistic realm. It cannot be measured, right? You agree?
I could make any number of propositions that could be
Okay, but
possible.
let's just assume.
Why don't we stick with Occam's razor?
Oh my god. Okay, this Occam's razor doesn't even apply here because both are the same simplistic, okay? So first,
No,
yeah,
it's
yeah, they're
not
both
a
one exists in one realm, the other exists in another. This is okay, the
the
Occam's
realm.
razor doesn't even apply here, okay? So first, right? Let's assume that the mind is immaterial. Does that mean that we can't measure it, right?
I don't. If you're manifesting part of your consciousness in some alternate realm, I don't care. Like that's
AJ,
not
I'm
important to IQ
asking
test.
AJ, I'm literally trying to reckon with you. This is a very simple proposition. If the mind is immaterial, do you think you can measure it?
If anything's manifesting in a way that can be measured, then that can be measured. I don't know. I honestly philosophically don't understand
I'm
what you're
glad.
saying, but it
Okay.
doesn't matter,
You know what,
right?
AJ? Let's just move on from this point because obviously you don't understand the philosophical justifications. I can assume that we live in a material realm and that everything's material. So let's just move on to my third critique.
I
Because
do want to
obviously,
let AJ
Okay, good.
finish his response if you had one or if you don't want to.
Yeah. So basically, my only premise is scientifically, we just assume even if you're, let's say, manifesting some type of, outside gene, outside environment, some sort of consciousness or some sort of mind thing that is like not just whatever. Even still, like if we factor for genes, then whatever supernatural event that's coming out of your head is still factored for. It doesn't really matter, right? So as long as we can,
I don't understand.
factor for genes, then it's done.
Okay, so how do you solve the equal environmental assumption? That's the third critique.
Yeah. So for example, the equal environment assumption, like we've done pretty good comprehensive analyses on whether, we changing the environments actually of like for example, what critique would you have? Because I could give you some like meta analyses on stuff, but like what critique would you have?
Okay,
I'll let you play
so the main
offensive.
critique, right, is that in a twin study, right, you're
Mhm.
essentially assuming that the monozygotic twins and the dizygotic twins have the same exact environments. That's essentially like this is every person agrees here. Some people believe that that assumption is justified because they do have the same environment, right? But I don't believe it is, and I can give some preliminary research as to why it isn't. So I assume you're familiar. So here, this is 𝘱𝗶𝘀𝗰𝗋 et al. 2015.
I haven't read much on the EEA, but I'll check it out. I'll be real.
Here you go.
We'll see how
Oh
it goes.
no, AJ, you quoted Emil Kierkegaard.
No, I didn't know. That's just a website. It's from Johnson.
Yo,
you sort of-
Pate.
Oh no, dude, like that makes that ruins kind of my credibility for you because that's like You know
Wait,
how
isn't
like
that the wait? I thought that was the
you know,
philosopher.
you know how incredible he is, right? Like
Oh,
No, no, no.
Søren, sorry.
For Emil Kierkegaard, he's a researcher. But like, for example, if he hosts a paper on his website so you can access it for free, I really don't care if it's Adolf Hitler. I'll use the freaking. Oh, sorry, I shouldn't say that word. But on a YouTube. But it doesn't really matter.
I'm sorry, that's my fault. I thought you were talking about the philosopher. Anyway,
No, you're good. But if you know, like Satan himself uploads like essays on his website, and I use the link, I don't think that's like a bad
Okay,
thing.
so these are 4 studies affirming the validity of the EEA. Some of these include cohort effects influencing these things. They talk about why you can in fact infer that
You mean not accepting the EA?
no. These are studies that like affirm the negate the EA. My bad.
Okay.
I'm tired right now. Dude, I've done so much
Okay.
shit today. Yeah. Okay, go ahead.
Mhm. So, for example, so that one's on diseases. The first one's on schizophrenia. The third one's on. It's loading.
Well, these all apply because they use twin studies, right?
I know. So, these are individual studies. They seem to be pretty good. I won't necessarily dispute the study themselves. I'll just like cite some meta-analyses. Okay. Please don't clip that, guys. Don't clip that. Okay.
wait, is he like a bad person? I don't know who he is.
Hitler?
Mao
Yeah,
Zedong,
he's pretty bad.
I thought you were talking about the freaking. I thought you were talking about the.
Kierkegaard's a controversial researcher.
Bruh, I said based after that. I was talking about the Sioran.
I know. I knew you were
No.
talking about
He's a
Kierkegaard.
bachelor's in linguistics and thinks he knows stuff about IQ. That's like insane to me.
Hey, James Flynn was pretty epic, but James Flynn was also a bachelor's in poli-sci, so that was his only
Yeah, I
credential.
mean,
But he's still
sure,
pretty
but
big,
like,
so it doesn't really matter.
Bruh, what do you mean, John? What are you talking about? Here, I'll show you. Bruh.
Okay, this is
So this it's definitely older. It's from the 70s, but this was at least at the time the most comprehensive analyses on the equal environments assumption. It was also like a comprehensive review of the literature was done in 2014, which included that. It was one of the biggest studies. That's why I include that just by itself. But Felsen 2014, the second one, does a comprehensively reviews the evidence on EEA, and its analysis shows that that like, for example, things like, oh well, Joe rather than John wore different clothes or different things. It doesn't really change the correlations. Like, so for example, differences between monozygotic or dizygotic twins doesn't change the overall correlation, like just from the systematic analysis.
okay. So it says here that right off the bat, there's one thing here. It reanalyzes data from Lolan and Nichols. I already have a critique of Lolan and Nichols. The second thing is that the study, the last section or the last sentence of the abstract of the study says, quote, results support a middle ground position. It is likely that the EEA is not strictly valid for most outcomes, but the resulting bias is likely modest.
Yeah. So if you read in the study, for example, it breaks it down by trait. Cognitive ability isn't affected at all. It is negligibly affected. Okay. So for things like some certain like disability,
is this linking to the same? Wait, one sec. Give me 1 second.
I can. Let me see if I can give you the paper.
Where is the Lolan and Nichols study? Because I have a critique of that.
Yeah. What's it?
I think it's just linking to the same study, man.
What?
But yeah, I have a critique. So there's a couple of things. So Lolan and Nichols was a questionnaire test, right? So I'll quote J. Joseph here. So, quote, Siegel et al. Referred to the landmark study of Lowland and Nichols based on twin scores on the National Merit Scholarship Test. These authors assumed that similarity of treatment can be measured from mailed self-reporting questionnaires, but it is well known that such instruments have weaknesses of biased impressions, poor memory, and poor reliabilities of only 0.3 to 0.5. See Richardson and Norgate 2005 for references. I actually cited that in our little private chat. These problems were clearly reflected in the pattern of results. Lowland and Nichols' parent questionnaire contained 56 treatment-related items to both which parents could respond: one, twin, one only, twin, two only, both twins, and neither twin. It seemed that parents treated their twins remarkably alike, reporting that they had treated one, their male MZ twins, the same on 99.14% of the questions, two, their female MZ twins on 98.98% of the questions, three, their male DZ twins, the same on 97.44% of the questions, and four, their female dizygotic twins, the same on 97.9% of the questions. Combining all responses, parents answered neither twin or both twins 98.3% of the time. According to Lowland and Nichols, quote, it was exceptional for a parent to mark any treatment item as different for the twins. For the identicals, it was in fact positively rare. Clearly, rather than accurate memory, parents answered questions on the basis of an idealized image of their child rearing practices. This is backed up by Joseph 2004. Lowland and Nichols 1976 themselves wrote that their results, quote, do not altogether exclude a completely environmentalist position and show that it, quote, operates in a remarkably mysterious ways. This highly flawed study hardly
just look at the
evidence
comprehensive
that
just look at the systematic analysis then, right? So for example, I think Richard Norgate's response, I'll be real, I think it is overblown, specifically because, like, for example, if we're looking at his study, like, he even admits himself that there are moderate correlations between like parent response rates, and I actually totally accept that. Like, for example, parent response rates to questions like how differently did you how differently did you treat your kids, right? Like, there's different ways you can analyze this, right? So different lines of evidence that might point to the same picture. And plus, so for example, if we're looking at cognitive ability, let me pull this up really fast. So sure. Barnes et al. 24. I think Barnes et al. 24. Sorry, Barnes et al. 14. If I'm not mistaken, I'll send that to you. Like, I will say it is funny because, like, Richardson and Norgate, I think these guys are responding to who are these guys responding to? Let me double check. Let me organize my thoughts here. It's going to take like 4.5 seconds. I'll be real.
Is this the violations of like the random mating, like this, like random mating? Like I have
No.
a response to this.
No, it's like I think that's well, it could, like.
Oh yeah, this is the study. Yeah, this is the random mating study.
Well, look past that. Like, it does violations on the EA.
Oh yeah, I've read the study. This is the criminology study. Yeah, this is the one about the assortive mating, right? It counteracts the results of the EEA.
Well, no. That's not what I want to point from it. And there's 2 criminology studies. It's funny because, like, for example, there are a lot of like philosophical scientists who which, not to rag on that, but who question like the equal environments assumptions. Do twins?
Oh shit.
Oh, he's
Oops,
here.
my bad.
Oh, is he just?
It cut out for some reason.
Well,
My
you
bad.
scared me. I didn't even see. All right, go ahead.
No, it's okay.
Okay.
It's okay. Go ahead. My bad.
But some philosophical critiques who are saying, what if twins aren't actually having a similar environment enough? And what if these effects from these non-similar environments are affecting these traits to any significant degree? Well, good thing we can empirically test this. Here, actually, this one's the second one I sent. I think that's the one I wanted to send. Let me double check. These are very similar papers.
Mathematical.
No,
John Prawl, right?
Nope, it was the first one. Sorry, ignore the second one.
Okay.
But the second one actually does go over gene environment interaction and how, like, the review of the literature doesn't show that much of an effect, if you wanted to check that out. But yeah, so the first one, which is talking about like generalizability of twin-based research.
Oh, yes, I've read this study. I believe Burton Simons actually did a rebuttal to this. Oh, my bad, it fell again. Burton Simons actually did a rebuttal to this study. Let me find it. Give me one sec. I do not have it in this document. I guess I don't have it in this document. One sec.
And I'll just add one last study
Yeah,
in there
here it is.
really fast. Oh, okay.
This is here. So this is quote from the Burton Simons rebuttal to the Burton Simons 15 as well as Joseph 15. I can cite both of these. Let me read a little excerpt from this. Quote, Barnes et al. Responded to our article by focusing on the methodological critique of twin studies, especially the EEA, and attempted to defend the heritability study method in the post-genomic era while ignoring our fundamental conceptual objections. To be sure, we are disappointed that Barnes et al. Did not engage with our conceptual critique, but not surprised, given that recent advances in molecular genomics debunk the biological assumptions that undergird heritability studies. The only way to justify heritability studies is to ignore or dismiss this evidence as quote-unquote fanciful, for example. Heritability studies rely on a conception of genetic influence uninformed by basic principles of genetics and by advances in molecular genomics in recent decades. Although such a deterministic model of genetic function may be ideally suited for heritability studies, it is chimerical. I'd like to provide you with both of these studies, J. Joseph 15 as well as Burt Simons 15, that directly respond to the claims made in Barnes 2014.
Well, I'm okay if they conceptually don't address this, and I'll give you one reason why. And this is one reason why, like, if the conceptualization of the problem is what we're looking for, then this would not be okay. I would agree. But, or at least I could understand why people wouldn't agree. But if we're actually just trying to find the effect, like what we're looking for is heritability, I don't think it actually makes a difference because they do, because the critique is mainly on, if I'm not mistaken, you can correct me if I'm wrong. If I'm not mistaken, the critique is mainly on the conceptualization that Barnes et al. Takes. However, if Barnes et al. Is going about and seeing the statistical significance of twins being treated differently, right, and that already violates, that quote unquote violates the assumption in Burton Simon's eyes. But if it's producing the same statistical effect, like a negligible difference correlationally between cognitive abilities with twins that are being treated differently, then it's like, okay, who cares?
Well, the problem here is twofold, right? So number one, I've actually read the Barnes 2014 paper. Unironically, AJ, I found this to be like one of the worst papers I've ever read. Like it was completely unprofessional. Like no, this is like an attack. It's just like halfway through the article they talk about how they're politically influenced. Like it's just like it's really weird. But like the major thing is that like when we're talking about the Barnes et al. Study, right? We have to keep in mind that that study was supposed to address a conceptual problem with twin studies, right? So if they aren't attacking the conceptual problem, then they're not addressing the critique, right?
Right, and if the critique,
to go even further than this, right? The Burt Simons 2015 study reanalyzes the data from the Barnes et al. 2014 study, and actually shows that the algebra that they do to get away with this like methodological flaw is just not good math. It's not good data analysis.
The 2015 one?
Yeah, the 2015 Burt Simons rebuttal. I believe there's also a response by J. Joseph, but I don't think that's directly
because your first critique saying like their attack didn't accept the conceptual critique. It's like I'm agreeing, right? It's like if that's not actually having a big effect, like the conceptualization of how they're doing it, then it's fine. It's like there's different lines of evidence that lead to this conclusion that the EEA is valid enough for twin studies, right? So you can do like one, it's like the shared environment, the effect of shared environment decreases with age, and you can look at the laws of behavioral genetics to see that the shared environment after a while doesn't become that much of a issue. But even still, if we are considering it an issue, it's like there's two different like experimental ways we can look at it, right? We can look at doppelgangers. One, I think I think Barnes's data is valid enough. I mean, I think that if I'm not mistaken, the math they were critiquing Barnes on was like the simulations of what would happen if they had different if the twins were treated differently, how it would go down or up the heritability estimate, because that's the math they do in the paper. But even still, if we look at other lines of evidence, I mean, like there's several lines of evidence showing us the EEA assumption is valid enough for twin studies. Like,
Okay, so yeah, so you provided the one study which was from Felton, I believe. We kind of agreed that the surveys there probably aren't that valid, and then you did with the Barn, the 2014 one. So the Burt Simmons 15 one response to that. So do you have any other lines of evidence that you'd like to provide?
Before we go
sure.
on, I do want to. Can we possibly wrap up at 11 if that works with people, or if you
Oh
guys need
yeah,
to
I'd
keep
love to
going?
make a closing statement. Yeah.
Yeah,
Sure.
well, let AJ respond
Oh no,
and that
no,
stuff.
you know what I mean. Like
I want to end at
I want
11.
to wrap
Yeah.
it up too. Yeah.
Go
Uh,
ahead.
So, for example, doppelgangers that look similar, and so doppelgangers that look similar because there should be some type of concordance if they're being treated differently. And then another thing is like misclassified twins, right? So twins that they thought were monozygotic but were actually dizygotic, or they thought were
Oh.
dizygotic but were actually monozygotic. Misclassified twin studies show this. I'll send the data in the chat.
I think I
Yeah.
have a response to the misclassified twin study. In regards to whether doppelgangers are treated differently, I think the main focus is if they were like identical. Like, I think it makes sense that they would be treated the same.
Well, for example, one way you could check is like, for example, the scale on which people look more similar or dissimilar, and the scale of concordance, right? Because trying to look at just a simple cross-sectional peak, yeah, I could understand that. But as you get more of a certain direction and nothing changes, then it doesn't really give a good.
Well, I mean, sure. It's just like we have to make sure that we this assumption that like the monozygotic twins and the dizygotic twins have the same environment is like correct if we want to like make sure that the twin studies are valid. So could I have the two studies that you proposed, or I guess used to back up the EEA?
Sure. Here's the doppelganger study, and here's the replication of the doppelganger study. Here is the
Siegel. This is. Oh yeah, I know Siegel. One sec.
thoughts on Siegel?
I'm not that. Okay, so this is
And the next two studies I'm bringing you
wait,
are
this one.
two studies on misclassified twins.
When was
And
this
I do want to bring it.
When was this one published? 13.
One older one from the 80s, and then a replication from 2013. But basically, I do want to bring an overarching point. It's like how we come to usual scientific hypotheses to see if it's correct. You can look at multiple lines of evidence approaching at different angles, and if they generally show the same point, then we usually accept it to be true. So like that's how we come up with like the Big Bang or tectonic theory or whatever.
Yeah.
But for example, if we're using from like doppelganger or facial attractiveness is another way you can look at it, or misclassified twins, or self-reported estimates, or stuff like that, and they all generally, right, there could be some individual methodological things which might skew the data, but if they're all pointing towards the same direction, then we usually
Okay, so I have a response to the SCAR study that you provided, as well as the Siegel study. So the first one, it's going to contain all of them. So basically, the first test of the EEA was that of SCAR, which basically compared the effective perceived zygosity as purported. And then the same one was basically used by SCAR and Seltzman in 1979. Right? The problem is the authors concluded, so the question was whether co-twins were found to resemble each other on 4 different cognitive tests according to their true or perceived zygosities. The authors concluded that it wasn't, but what is revealing about the study is the riskiness of using either perceived zygosity or ratings of physical similarity as guides to treatment. Twins' judgment of their own zygosity correlated only 0.55 with self-ratings of resemblance. Also, ratings of twins' zygosity by psychologists using only black and white photographs turned out to be more accurate than those are the twins themselves, correlation with 0.66 of blood group differences compared with only 0.57. The psychologist's rating and twins' judgment of similarity also correlated only moderately at 0.51. Thus, twins' perceptions of their similarity are not very reliable guides to either their mutual resemblance or others' perceptions of their resemblance. Perhaps it's not that surprising, therefore, that Scarron's Carter-Saltzman reported, quote, a highly inconsistent pattern of results across tests. For the modern zygotic twins, it was found that, quote, the Raven's matrices scores were significantly predicted by differences in appearance as rated by 8 psychologists. This is on page 535.
Like a difference of how they look like?
Yes, differences in appearances were Raven's matrices score differences were significantly predicted by differences in appearance.
Is this for the twins, or is this just just generally be people that look different, like?
This is for the monozygotic twins, yes.
Okay.
So a strong negation of the EEA in that differences in appearance presumed to lead to differences in treatment, lead to differences in test scores. For the sample as a whole, larger differences in Raven's scores were associated with smaller differences in appearance ratings. You can read the study that I provided there, which was Richardson and Norgate for that actual hypothesis. Yeah, I generally don't accept Scar's.
Sorry, can you put me what you're reading in the chat? I'm sorry.
Analysis. That was just what I had written that rebuttal down for Scar. Yeah. If you want me to cite the one where like the differences in appearance led to differences in test scores, that's right there in the study that you cited, and then primarily the Richardson and Norgate study that I provided also provides that precise explanation. So this conclusion is actually really important to understand.
I mean, like, did you address the Conley et al. 2013 paper at all? Because this is just a replica, the replication of the Scar paper.
Yeah, I read the study. This is using the same exact methods, so it basically perceived zygosity and stuff, right? So this goes past the same exact critiques, which is that perceived as zygosity doesn't seem to actually reflect like self-resemblance, which is what is actually important. And then you still find inconsistent patterns of results, which still end up finding that differences in appearance correlate with differences in IQ scores. And let me just synthesize what this means, because if differences in appearance actually predict different IQ scores, what that means is if you actually look different from your twin, you're probably going to have a different IQ score, meaning that the actual environmental differences are in fact caused by the differences between the twins. So we cannot assume that these environments are the same. That is the problem with twin studies.
Right. I'll have to double check that, because I'm not sure if that's actually I'm not sure if that was actually the case. It could be. I just need to double check that. Are you sure Conley's is a self-reported behavior?
Yes,
self-reported.
Yeah. This does the this is quote self-perception of twin zygosity and the national longitudinal study of adolescent health. Right?
Twins who are genetically well, it's saying like the problem was that twins whose genetic similarities misperceived by themselves and other provide a critical test of adequacy of this assumption. So I thought it critiqued.
Yeah, so it's basically self-perceived zygosity, which doesn't correlate very well with like actual self-perception.
Yes, but for example, I'll have to double check this, because I'm not sure. You could totally be right.
Okay.
I'll just have to double check it. Not gonna lie.
Okay,
So,
we should probably move on to closing statements, right?
Yeah, I want to be able to end this. So I'll have Paney go first and I'll have AJ finish.
Okay. So I think what's important in this debate is something that's extremely important as well. I think it's important to understand this topic is complicated. This topic is extremely, extremely complicated, right? The main thing to take away is that nobody knows what the fuck is going on here. I'm just gonna say it. Nobody knows anything about IQ at this point. Like, there's so many different tangled webs of like different assumptions we make, different models we create. But I think the thing you should take away from this debate is that there is a debate. Any claim that one side of this debate is inherently correct over the other is wrong. And any justification that this is used to prove that IQ is genetic and ergo that certain races might have different levels of genetic influence and intelligence. I'm not saying IJ is making that statement, but this is justification that can be used for those kinds of statements, right? I'm saying that this is not something you should take away. You should take away from this debate that there is a debate and that there should not be a definitive conclusion as to what is correct. And I believe primarily that I, in fact, was the primary winner of this debate, mainly because I believe that most of my evidence wasn't, addressed in much of a parsimonious fashion. I believe that most of my evidence was rejected by certain studies, which I then provided rebuttals to those studies. And I think the discussion on the equal environmental assumption kind of highlights this, right? Because the equal environmental assumption discussion kind of proved that a lot of the stuff surrounding has a lot of really missing ends, loose ends, ways in which we can improve our methodologies. I think, as does AJ, that we want to reach a way in which we can determine what intelligence actually is. I don't believe sticking to outdated, outperformed, inconclusive methods of discovery are going to get us to that conclusion. And with that, I'll hand it over to AJ.
All right, thank you.
I will say, this was awesome. Thank you for joining us. This was really cool. I will say, if no matter who wins or loses the debate, it's like if people watching are interested in understanding how intelligence works, that's a net win, right? And I do want to say this debate is still going on, and I would actually attribute this to more maybe political things, because anything to do with how we are, how humans are, that's something that hits you right, like that's something that hits you hard, And heck, environmentarian models of intelligence, environmentarian beliefs have led to things like social control and like Mao Zedong policies that engineer people, right? So any scientific position could lead to pretty bad policy positions. So we have to make sure we're interpreting it correctly. The last thing I'll say is I do think the scientific consensus, and not just in psychology or survey respondents, but in encyclopedia databases and empirical methods, empirical studies, all three of these lines and all primers on whatever you want to look at, I do think these all say the same thing, is because the literature is pretty clear on this complex and hard topic. And so I'm glad we had a discussion about it, and I'll hand it over to you, John.
Awesome stuff. Hi, Aggie. Hi, Josh. Damn, Mao Zedong. It's a bad thing. Long live Mao.
Okay, guys.
Thank you guys for coming on. This was a long, and I didn't understand any of it, but it was a good discussion.
No problem, Joe.
Appreciate you guys coming on. My boy Panini.
Let's go, Aggie. Come on, Aggie. No.
Anyways,
AJ, unironically, you're a civil guy. I like having discussions with you. I'm extremely sorry for calling you slimy. That was something that I should never have done. You are an awesome guy, and I want to have future discussions with you. Even though it got a bit heated on some of the more like intricate aspects of intelligence, what the models were, what the statistical analyses were, I think we can bond and we can say, we just want to make the world a better place, right? So
true.
Okay, what you have conceded that he's not slimy.
No, I mean,
that's a win. Okay.
AJ is a slippery motherfucker. No.
All right.
He's okay.
All right. Otherwise. Oh my god, I'm editing this broadcast. Anyways, bye guys.
Hey, what's up? What? Hello?
He looks like 𝘄𝗲𝗯𝘀𝗶𝘁𝗲. I'm dropping that in the chat.
There's so much funny shit that happened at the debate. Anyway, hey Panini.
Oh my god. I don't even know.
Okay. Panini. Can you hear me, buddy?
Yeah, what's up?
Okay. Good. The duelist point was weird.
Dude, I was only making that point just to show. Okay, that was I understand that.
That was him like not assuming anything, right? That was the point you were trying to go for there. I joined kind of late.
Okay, what I was trying to say was that in order for him to say that like twin studies are valid, he has to assume that consciousness is material, and then he's just bypassing this whole debate. But I was just saying that he was assuming. It was a weird point. I should have made it. Yeah, but dude, I got him at the late part of the debate. I was just fucking. Oh, dude, I was just like bullet. Oh my god. So...
You have to watch. I have to watch through it. Actually, I'm pretty late today.
No.
But yeah, like it was so funny too. Like, literally in like the closing conclusion, bro. His entire thesis was that it's a political debate, so you would have fucking objections to it. Like, oh my god. I hate it so
Okay,
much.
wait, I zoned out for the Mal point. What? Why was everyone talking about Mal?
Oh wait, but Blue, who do you think won that?
From what I saw, you, but it's also because of the optics.
Yeah, why
Like
this?
AJ just has like awful rhetoric, like some of the worst I've ever seen. It's actually kind of humiliating watching him try and formulate like a coherent sentence without sounding like I guess
He doesn't.
incredibly socially
He doesn't
awkward.
like properly answer any of like the points you make.
But no,
He's just kind of back
Panini.
on-
I think that you won.
Okay.
I think there were. I mean, the whole mic thing was not great for how you looked. Just like how loud you were. But
Sorry,
You're also brown too, so I think that kind of like drops a couple points as well.
wait, I'm gonna watch the
No,
last 2 minutes.
It was just because the chat was molding. Dude, at the beginning of the debate, oh my god, you should have seen the cope. Oh my god, dude.
Bro,
Everyone
Nikolai
coping
was so dumb, bro.
Bro, I have to go pee so bad, bro. Give me 1 sec.
That was an interesting debate.
Wasn't there, but I know Panini won.
Yeah. Bro, I missed like debating, bro.
I don't.
Wish we can like rewind time a couple of months, bro. It's like the political discord. You know,
We have to make sure we're. Last thing I'll say, I do think the scientific consensus, and not just college surveys, but in media databases and empirical methods, all three of these lines are
Unironically, AJ was talking about Mao's controlling policies like that's not a good thing. Like, I was so based when Mao controlled the people. I love that.
maybe that's kind of like a fucking strong man, bro. Literally like the mass line of some of the most democratic shit I've ever seen.
This is gonna be terrible for the economy.
What are you doing?
What is who doing?
It doesn't look like anything. Your camera's not on.
What are you talking about? I'm confused.
Am I talking to myself?
Wait, who are you talking to?
You.
Oh,